9.5, testing the difference between two variances. A random sample of the average gas prices in Oregon and Washington is listed below. At the level of significance of 0.05, can it be concluded that there is a difference in variances in average gas prices between the two states? Use the traditional method. So the following data is from OregonLive.com and WashingtonGasPrices.com. So Oregon and Washington. Oregon is 283, 285, 287, 289, and 291. Washington, 254, 257, 260, 261, and 263. So for these problems, you have to find a null hypothesis, which is H0, and then an alternative hypothesis, which is H1. So in this case, it's sigma 1 squared equals sigma 2 squared for the null hypothesis, and then the alternative hypothesis is sigma 1 squared does not equal sigma 2 squared. So the next thing that you have to do to finish this problem is go to, or find the critical value. So you go to F4, inverse F, enter in 0.025, because the alpha value is 0.05, and then 4 and 4, and you get the two 4 values from n minus 1, and that is the degrees of freedom, and there's 5 samples, so it's 5 minus 1 gets you 4. And then you do that again for the second critical value, inverse F, but this time you enter 0.975 because that is the area left over. So the first critical value is 0.104. The second critical value is 9.605. The next step of this problem is to find the test value. So you find the test value by doing S1 squared over S2 squared. And you get the S1 and the S2 values in your calculator. But you have to put in the Oregon data values in list 1, the Washington data values in list 2. After you enter in those values into list 1 and 2, you go to F4, 1 var stats, and then the first blank is list 1, the second blank is list 2, frequency is 1, and then you need the little squiggly brackets, and you repeat this again to find the S2 value. So you do it once for S1 and then S2. So those values come out to be 0.032, and then you have to square it, and then S2 is 0.035, and again you have to square it. So the test value comes out to 0.0010 over 0.0012, which gets you 0.833. That is your final test value. Next, you have to draw the graph, and it looks like this, and then in the tails is 0.025, 0.025, and then 0 down here, and 0.975 is the area left over. It's 95%, so 0.95, however you want to do it. And then the first critical value that we found was 0.104, so I'll put that right here. And then the second one was 9.605, so that is right here. And then the test value goes right about there, 0.833. And then you need to shade the critical region. So we'll shade right here. And because the test value lands in the critical region, you reject. And the statement would be, there is evidence to claim the average gas prices are different. And that is all you have to do for these types of problems.